Sure.
Are we gonna have a set time for quizzes?
What?
Are we gonna have a set time for quizzes?
What does that mean?
I mean, the first time we had a quiz, it was the first 5
No,
minutes
I
class.
don't
The
have it.
second time,
No,
it's
no, I don't. No.
sorry, what does that mean? What does no mean?
It means that it depends. Sometimes the quiz is going to be the beginning of the class, and sometimes it's going to be in the middle, and sometimes it's going to be the end. So that
But
was your question.
you won't tell us the lecture before.
No, because as I explained earlier, for me, attendance is important. So if you're attending my class, you're going to be in the class the whole time. That's
Yeah,
the
I just get nervous when I get blindsided by quizzes. So I just wanted to let you know.
No, just because I want, as I explained earlier, so I want students to be, and I mentioned when is the class for quizzes. If you could not join the other day, at least you know that we have a quiz day. So yeah, probably, yeah.
It's
And
okay. I
then
was
it's
just
not,
expecting it to be a little bit later.
no, and then the other thing is that the quizzes is already, and then nowadays it's everything about like merge, so a merge algorithm. You can look it up earlier. So I told you guys, so there is a book, and then you have time to look up about this question. So probably it's better not to be nervous. I don't know. So let me start teaching the class. We need to just jump because I need to teach. I need to explain some of the problems for the midterm too.
I have a question, not about the quiz.
Sure.
So you said our homework was going to be due the day of the midterm, but we still haven't received the homework.
No, as I explained, I think I do have an issue with this class now. So you guys probably, I'm not that clear, or you guys don't listen to me. I don't know. Because as I explained yesterday, so I'm going to postpone the due date for the homework, because some of the topic that I'm going to teach right now, we're going to be in the homework, but it's not going to be in the midterm. So I'm trying to postpone it after midterm. Does it make sense?
Yeah, thank you. My bad.
No worries. No, I'm just trying to be clear. So I'm not, the things that teaching the class online is a little challenging. Most of the time, you guys are just nagging about the quiz and why it's not. But whenever I ask anybody has any question, nobody has any question. Most of the time, whole the class is silent. So it's easy.
Except for me, my professor.
What?
Except for me, my professor.
No, you talk, but most 90% of the class, I know some of you guys because you write in a chat, or I know that you talk, you ask, but 99% of the class, you guys are silent when you are nagging or something. It's just like, oh, so you guys don't listen to me, you're not in the class, so why you're nagging about that? But probably the things I want to mention, so this class it has, probably this class needs to, it's more challenging when you have it in the summer than when you are in the whole semester. Whole semester, because there's so many topics that you need to be done during the class, because this analyzer algorithm is a really important class for a computer science student. Probably, I think most of you are a computer student. Am I right?
I think we're all. This is a major required class.
Yeah. So that's the thing. When you don't ask question or any time, just like for the other question, or like this quiz or another time, anytime you, or during the midterm, if you have any question, please ask. So I cannot guess what you have in your mind. So, and at the end, like arguing with me about like this thing is not gonna help. So probably if you have any question during the section, if some part is hard for you to understand about the homework or the other thing, it's probably better to ask. And one more thing, like if you have any question about the homework, don't wait until the last day to just have an office hour or something. At least reach out to me 2 or 3 days earlier so I can plan for that. So other than that, I want to help you guys. And the reason, most of the time in my classes, I'm not going to post the quiz earlier. Most of the time, I just give the quiz that day. They don't know what is the quiz going to be. Now I'm trying to help because it's a summer class, I'm trying to post the quiz earlier. I'm just trying to just post. I'm going to explain some of the midterm questions today to just give you some idea about what's going to be in the midterm. you guys have some idea. So that's the thing. So that's the thing I'm trying to help, but you're nagging about it. It's like, okay, you don't respect and you don't like it. You just prefer that I just don't post the quizzes and just write it right away and you will see. So
No, can we just please keep the quizzes posted before?
yeah. No, I don't want to punish anybody. I just trying to say, okay, I'm trying
Honestly,
to be.
Sometimes when we finish the quiz, like for example, like 18 minutes, but we have to take a picture and still upload it, so that's gonna take a while too. I was just
I just suggest, because you have the quiz earlier, don't start it like the day. I started right earlier, just I don't know. I don't ask you guys to type it in the quiz. So probably if you started like this morning to just write it in a paper, like just make sure, because in 20 minutes, I know this question is hard. 20 minutes is not enough. I know that myself. That's the reason I posted the question earlier, because these things you need to think and you need to know, oh, how the merge sort work, write a pseudocode. Probably is not a good idea to just start writing this question in the quiz. Does it make sense?
Oh, can I say something really quick? I know that it's not something you can control because the TA is late, but I just don't have any feedback on any of my quizzes, so I just don't know if like my handwriting is too bad or like.
I'm
You know what I mean?
I'm really sorry, guys, but that's not in my hand. The only things I
No,
can
I
do
understand. I
tomorrow-
just wanted to
no,
mention it.
the only things I will do for sure, tomorrow's Friday, I will put all my weekend to grade everything. All the quizzes, homework and everything. I will do it myself, but this is most of the time I have TA to do these things, but I will do it this week myself. All
okay.
out.
I have a question. Just in case, like in the next quiz, can you just mark the questions, like say, oh, this is gonna be on the quiz, and maybe
Sure,
just maybe put on an announcement too, saying, oh, this is gonna be on the quiz, this is gonna be on the quiz, just for us to get like early head start.
You guys, just you don't want to check the notes anymore. Sure,
And
I
do,
can
do you do you want me to be the grader? I can grade,
No,
but I
worries.
get an A, but I'll do the grading.
No, I can do it. Don't worry. I will try to post the quiz.
Okay.
No, I don't need you guys, any of you guys grade. I will grade myself. Don't worry.
I'll work for free, like you don't even have to pay me. Like
No, I can do it. Don't worry. But it's interesting, but yeah, I will do it. Self-grade quiz. Oh my gosh, yeah, that would probably everybody gonna be 100, maybe 110. That's fine. No, I just trying to be, trying my best to make sure you got something out of this course. As you mentioned, it's like an important course in computer science, and then trying to post this thing. And the reason I post the quiz, I just want you guys to try it, because if this kind of question being the final exam, but just one more thing, one more thing, explain everything in detail. So the exam is on June 13. One more time, let me write it. Don't come and just complain later and say, oh, I didn't tell you guys. So okay, exam is in June 13. It start from 5 to 7. No, it's no extension. It means after 7 it's gonna be closed. Open book, internet, anything you want to use. Just don't copy paste. Without reference. And then one more thing, I know that you guys, some of them use Discord and other platform. Don't post your solution there during the exam, because I'm grading them and then I use Gradescope here, just gonna show that if there is this is gonna show that if there is any plagiarism or cheating. So it's gonna show 20%, 30%, 50%. Don't make it hard for yourself or myself, So if you use anything, just put a reference probably. Does it make sense?
Can I ask a quick question? This might be silly. Do you mean are you allowed to reference like the textbook and stuff? But are you also allowed to reference like Stack Overflow?
Yeah, if you're gonna get your solution over a Stack Overflow, please do so. Yeah, I don't know that you guys can check your Stack Overflow over the solution for the midterm. Yeah, like
Well,
if you
not
wanna
well,
use
not
it.
whole, well, not whole like chunks, but like like I
You
got
know,
this
because
for loop off a Stack Overflow. I got this like
no, yeah, because the thing I'm not gonna because this system, this software based on all the data set that they have, they show how many the percent of the like copying or cheating. So it's gonna show that. So probably it's better to reference it.
But yeah,
I'm not gonna.
that's what I'm asking. I'm just like can we reference Stack Overflow?
Yeah, do whatever you think. Yeah, just add anything. With reference is okay. You just add the reference. So you want. The reason I just makes it open book and 2 hours, because if I put 2 days to respond, probably the question gonna be really hard. So I don't want to make your guys' life hard. So that's the reason I give you 2 hours so you can do anything. So
What
or
about,
you can do.
can we have it until midnight? That'd be a lot better.
Unfortunately, no. And then the other things, I don't want to do that. But if it's you prefer, I can make it closed book and just ask another proctor to just be. Everybody needs to turn on their Zoom, and then gonna have proctor. If you
Yeah,
prefer that.
2 hours is good.
We're gonna have to be on Zoom.
Probably the reason being is the reason I said because if I give you 2 hours like open book, problem is gonna be harder. If it's closed book and we have proctor, the problem is gonna be easier. So that's the difference. So that's the reason I'm suggesting. And one more thing, the reason I'm saying being in the Zoom call, because if you have any question by any chance, so I can respond. I will be there. So because there are questions, or probably you have some questions and you want to say, you can write a text to me in private or like in the Zoom, or just want to write it in the overall everybody see, and then anything. So you just unmute yourself and can ask questions. The reason I want you guys to be in Zoom, because I want to respond to any question you guys have. And the reason I put it 2 hours open book makes it easier for you guys to prove or just write it. If it's you think a little, it's gonna be harder because it's open book. But if you prefer maybe a little easier, I can do a proctor. We can have a proctor and be closed.
How many questions?
Probably I'm gonna have like 3 questions.
Three
And
questions.
questions gonna have part A, B, C, D, like different.
Is it
I think-
multiple choice?
No, it's not multiple choice. So it's open book. Why should I have multiple choice? Can you tell me why?
Wait, so it's 3 questions and on okay.
No, let me explain. I will, if you let me finish the partition part, so I will explain it. I just want to make sure this is clear. Let me. Probably I can, because in. So let's see. I want to finish inversion because that's going to be in the final, in the midterm. That's the reason I want to finish. Let me finish an inversion. So let me write it here. So actually, there are 3 questions. So there are different categories. For example, after finishing the inversion, so let me see. I finished the inversion. Okay, the inversion is not gonna be too into. Let me write which part is gonna be in the midterm. So we have lecture 10 actually. Okay, lecture 10.
I feel like the first 5 lectures should be multiple choice, because they were the ones like where like you just find the algorithm.
No. No, it's not gonna be multiple choices. So okay. Quick sort. Multiple choices is gonna be when there is no open book. So okay, so midterm. So let me start writing question about midterm. Midterm is gonna be Let me see, before inversion. Does it make sense? Is it clear? I just remove inversion from the midterm, so you have until the end of the quick sort.
Okay, so that's gonna be
What was your question?
We just both started talking at the same time. Sorry.
I'm so sorry, I didn't hear
I
you.
just want to check we're no longer doing number of inversions or like
No, we don't do inversion. I'm gonna instead of like, because we are talking about like Nazis 43, I wanna start writing some of the like some of the questions maybe being your final exam, midterm. So I wanna start writing some kind of question, give you some idea about what kind of question gonna be in exam. Does it make sense?
Have like a study
Yeah,
guide
that
day, like where we just
Yeah.
shoot-
Yeah, I'm gonna write some question. For example, I'm not gonna solve them. You can start practicing on them. So the things that when you have like open book is totally different than when you have like classical exam without writing something and then solving. So probably when you have open book, it's easier. It's because you can check your internet and there are so many resources. Okay. One of the type of questions. So probably let's start with what we learned here. One kind of question, you need to learn this one. I explain everything that I'm writing here, you can see it in the class. So I already solved one of these questions. Okay. This is one of the questions, this is gonna be this is like one of the kind of questions gonna be like in the class. So let's just start this one. I said the following. I'm using an algorithm which called backsort. Actually, the modified. This was another sort, which was in the book previous time, but that they remove it. The following sort is like a modified version of that. In the exam, in the midterm, I'm gonna ask this kind of question. I will write another algorithm like this one. This is one example. The name is backsort. What does backsort do actually? Well, probably I need to go to next page. Let me put it here. Try my best. So I'll say backsort. It gets the A, P, and R. So instead, it gets the list, it gets a start point and end point. We know that P is less than, prerequisite is P less than R. So what is gonna do? First step, if AP is greater than AR, so what we can do? AP you guys know what is swap. So what do you do when you do these things? What does that mean?
you swap the positions of the
A
elements.
what?
You swap the positions of the elements.
No, swapping, it means that you switch. Let me write something here. If I have this array, so A is gonna be 1, 2, 5, 6, and 8, and 3. If I swap these two, it means I change the position of this. It means I have 1, 2, 5, 6, 3 becoming 3 move to 8, 8 move to 3. This is the number. When I say if AP, as I mentioned, like 8 greater than 3, just swap them. Just move change the place. The position is gonna change. Does it make sense?
Can you explain one more time, Professor? Thank you.
Sure. You see that, the reason why we want to do this thing is sort. Sort, it wants to have everything in the order. So here I'm looking at everything. Everything is good. 1, 2, 5, 6 is good. The only things between 8 and 3, for example, they are not so. Let me write something, make it better maybe. Let's put this one 7. So everything is good up to here, but we can see 8 and 7 not in the order. When you say swap, it means change these two. Put 7 in this position, put 8 this way. Now it's become 1, 2, 5, 6, 7, 8. It means now it's sorted. As you can see, it's sorted. Does it make sense? It means that if some of the importances I need to explain again. I don't know, you have the data structure class, am I right?
You asked at the beginning of the semester, about half of us have taken it.
Yeah. Probably if this is the least, this is the number, which is going to be number 1, 2, 5, 6, or 8. If you have passed any, probably any language programming class, so this is the index. This index is index 0 in the programming, but we put it here 1 because we don't do coding. This is 2, 3, 5, 6, 7. When I say if A, P, and R, P is the index. It means if this number, if it's A of index 5 is greater than A of index 6, that's what's happening. Here I come here, I see, okay, the A in index 5 is greater than the A in index 6, swap it. It means change the position of these two. When I change the position of these two, it means this is going to be in position 6, this number, and this is going to be in position 5. That's the way it works. Does it make sense?
Yeah, thank you.
You're welcome. Okay. I swap these things. What's going to do next? I know this is number 2. Let's look at number 3. What does number 3 do? It says if P plus 1 is greater than or equal than R, it means that you already go out of the page, like here. For example, what was that one? P was number 5, P plus 1 is number 6. It means I check up to number 6. There is nothing after that. So it's okay, I return. There is nothing I need to do. But if it's not the case, what's going to happen? Else, I need to do this thing again. I need to calculate this one again. What do? I say, okay, let's calculate R minus P plus 1, because we already do this swap. So it's going to be divide by 3. We do this one. And then this is numbers. Sorry, something missing. Number 1, 2, 3. This is 4. This is number 5. This is number 6. What is number 6? It's the Q. This is the number. Number 6. Number 7. 7 is going to be bad sort of what? You get a start position, because you're going to start from P up to Q. So it's going to be R minus P, because R minus Q, because you're going to go up to there. R minus Q. And number 8, bad sort, is going to be A, P plus Q to R. What does that mean? Start from P, go to R minus Q, if Q here is coming here, and then from P plus Q, go to R, all of these things. And is it clear? Let me remove this one. Number 8, number 9. What is number 9? It's going to be bad sort. Number A, P, and R minus Q. This is the whole algorithm. If in the exam, I give you one algorithm, like I will write this one. What you can do, you need to just, first of all, play with it. Like start doing 1A, define 1A for yourself, as I explained earlier. Do a step by step and see what's the solution, how it works. And then the question is going to be this part, as I explained why you have a few parts. Second, use induction to length m r minus p plus 1 of a p to the r to prove the correctness bad sort. This is the way. Let me see. It means what I'm gonna do, I'm gonna prove this algorithm is correct by using induction. I have an example here. Let's go back and check when we had this one. Then we have it in lecture 9 and lecture 8. Like here. One of the example I showed here, just want to bring everything to show how I explain. For example, for merge sort, I have exact same thing. This is the format that you're going to have in your midterm. So one algorithm is going to be given, and then you can play with that, see what's this algorithm. As I explained, the bad sort means sorted. You do write a theorem, say, okay, there is for correctness, if there is one, like you see here, when I'm trying to prove, there is another algorithm in the middle, which is name is merge. If I have another algorithm, I need to assume this is already correct because I'm going to prove merge sort. Merge sort inside has merge. So I say, okay, let's assume that merge is true and I'm going to prove it. How do you prove it? You need to consider M for proving this one. I say R minus P plus 1. And then after you have this one, what do? You consider base case, which is going to be M equal to 1 and show this is, for example, if I have one number, so it's already proved that one number is sorted. And then what you are going to do? You are going to say, okay, M greater than 1. And I need to show that if I assume the merge sort is correct for this one, for all M greater than 1 and show these things and prove this one, for example, the length is less than this one. And I know if this is correct, if I add another element, it still is going to be correct. It means it's going to, based on the hypothesis, it's going to be sorted. That's the way you prove it. Does it make sense? Lecture, what is this lecture? Lecture 9. Is it clear?
Yeah, I get it.
So that's the reason. Then because now nobody's saying, and if only you just respond. So if you guys don't get it, I think you probably get it because nobody say anything. So just prove like merge sort from lecture. I think it was lecture 9. Yes, lecture 9. So that's the way. I will add some notes here. Note, if you have any algorithm inside your need to assume the correctness Does it make sense? If I have another algorithm inside my algorithm, I need to assume that this is already correct. Make sense?
Like merge for merge sort.
Yes. For example, let me write something. Let's write an example. Let me write an algorithm like algorithm A, like A. No. Like I have an algorithm exam A, like N. This is the A and this is number N. And then let's write something. Inside the exam, I have like question. No, sorry. Question. There is a question algorithm which consider A, N, and M. So if you are going to prove this one, For proving exam, you need to assume that question is already correct. Does it make sense? No. You assume this one and then you prove everything like what we have in the merge sort. You see how I prove merge sort? You need to do all of the steps. You need to use induction. You say, okay, I know, because the question was here. I asked the question, so okay, what was the question? So I said, okay, consider M equal to this one. It means for you, and then I say correctness of that sort by induction. I ask all the questions. It means you need to consider like base case and don't show if we consider it is correct for M minus 1, it's going to correct for M. Yeah, it's just for just question part, yeah. For the algorithm, inside the algorithm, just say, oh, we assume this is already correct. Because we are going to use it inside the algorithm. So that's the first part for the question, which I already explained how. Let's write part B. So what is the second part of the question could be? This is one of the examples. Maybe I write some algorithm, new algorithm. So write the relation of number of array comparison performed by that sort. Length. Okay, what is that? As I explained, this is recursion relation. What does that mean? It means you need to find the relationship for T of. Just write the relationship. Yeah. Let's go here, for example. Because it said in the question asked, okay, the relationship between the number of elements, it means n, the number of elements in the array. So let's solve this one, for example. How does it work? So what is the cost for this one, the first line? What is the cost for this? Anybody, what is the
0.
cost for that? Yeah, because there is no n there. The second part, swiping doesn't have any n. It's going to be 0 too. The next one is going to be 0. Return doesn't have any n here. But how about this one? This is going to be probably what?
Number 3.
Actually, this one is 0 too. It doesn't depend on the length. 3 numbers that you
Yeah, you're right.
This doesn't have anything. But this one, this 3, how does it work? The first one.
Shouldn't that be like the first third of the list? So it's n over
Yes.
3.
Let me teach you guys how we solve this one. Let's go here. What is the definition of Q? It's like R minus P plus 1 divided by 3. Let's have an example. It's okay. I have this array. How many we have? 1, 2, 3, 4, 5. This is gonna be, let's consider the indexes. This is index P equal to 1. And what is this one? What is this number? R. What is the number R? Okay, correct. 8. Let's consider this one. You say 8 minus 1 plus 1. 8 divided by 3. What is going to be the number?
2
It's
and
going to be 2
2/3. I
point
mean,
something. It's going to be 2 point something because, and then we get the floor, which is going to be Q equal to 2. Am I right?
yeah.
Okay. Now we say, okay, Q is equal to 2. Okay. Q is equal to 2. And then the first part, ask us go all the way from P to what? R minus Q. What does that mean? All the way, A, it's going to be considered from P, from 1 to all the way to, what is that? Q, R minus Q. R is 8, Q is 2. It's go all the way to 6. Am I right? So, what is the definition of this one? How many numbers here? If it's go 1 to 6. If I consider it from n, how many? What is an n?
Five?
How many elements do we have? Now, n is going to be the least number of elements. Yeah, what is the number of, how many number of elements we have?
8?
8. So we have 8. So we still consider, because, we consider this division, as you can see, this is really important number. This 3, it means it's going to divide everything by 3. If I do 8 by 3, what is the number? It's going to be 1. 3 point something. The 8 by 3, this is going to be 4. No, it's going to be,
Wait, that's 3.
yes, sorry.
It's not 3 point something,
two.
it's 2 point something.
Yes, 2 point something. Yes, this is going to be 3. And this is going to be number 2. Now we have 6 to 5. Now we calculate everything here. So it's okay. This is T of, we start from P up to R minus Q. So this is going to go from what? And then let's see. R1 to 6, the first one. And then how about the last one? So R minus, what is the, yes, R minus Q, and then Q, this one. This part is going to be number, I think it's going to be number 6 to 7. This part is going to be T of n over 3 because of the calculation. So it's going to be the higher numbers, n over 3. Because as you can see, when we go from 1 to 6, this is going to be less because it's going to be P plus Q to R. So this is going to be T of n minus n to the floor of 3. And this is going to be T and ceiling of 3. So now, and then what else do I have? That's the last part. So if I consider this is all 3, 0, and this is going to be this one, and this one, then it's going to be 3T of n. So you need to calculate them based on the, based on what we have here. So that's the way you need to do these things. So probably you need to keep going, calculating everything. So, and then writing, and then let's the next question. I need to talk about the other question too. So this is the next question. This is the text part, which is going to be part C. Use the master to find an asymptotic solution for this recurrent. Okay, and explain why it is bad. Why it says bad, so because based on this, yes, it's ceiling. So why, based on explanation, based on what you say, your quiz is hard, you don't understand. So that's the reason I try to break them down. So could write recursion to find the relationship, or the last one say you use the master. So I'm just trying to mention everything. Is it better? Is it more clear?
I understand.
Okay. This time, why? One of the most important things, you prove it in Master's theorem. When we say it's bad, the reason we say it's bad, I will explain it. The bad is because the
Does that mean
runtime is
slower
the,
than merge sort?
yeah, probably it's not only is merge sort. So for example, I don't know, you need to calculate. Maybe you will find something like this. T of n cube. It's really bad. As I explained, when n goes to like power of something, is it worse and worse? You remember I showed that like one league yesterday, draw everything and then it's go like this. It's the number and goes to like really go higher so fast. That's the reason it's bad. If you want to show any algorithm is bad, you need to show that the runtime is really, really huge. Depends on n. If the power is higher and higher, it means this algorithm is not a good algorithm, because changing the n is going to explode the algorithm. Does it make sense?
Yes.
So that's the first type of question. Okay, this is the first type that's going to be in your like midterm. The second part, so part 2 of the question. We have a T of n by, for example, I do have T, this one is n equal to 1 and n greater than 2, and then I have 2t n over 2 plus n log n. And then the first question is, first, part A is prove master theorem cannot be applied to this problem. Do you know why it not can be applied? You remember when I talk about master theorem? Do you remember when I talk about master theorem? So no, you cannot show third case because I already said you cannot. It means that there is no way you can use master theorem. No, that's not the case. You know, here in master theorem in lecture 8, I mentioned a few things. You need to just look at these things. That's the reason when you have open book exam is easier, because you can look at the notes. Or so let's see. Here, what do I have? I said for using master theorem, first, A should be greater than 1, B should be greater than 1, F and B should be asymptotically positive, and let T on be defined by this, then we can have these cases. It means this is some of the things that really, really important. You need to have F of n to be asymptotically positive. A greater than 1, B greater than 1, and that's it. And not only that one, if these two case doesn't hold, the first one and second one, the third one is when not only you need to show this is, and you need to show that for any epsilon, this is gonna hold. If this one is not holding, it means it's not correct. It means we cannot use case 3. Things that I check is not case 1, it's not case 2, and if this not gonna hold, is not case 3 either. So there is no way you can use master theorem for this problem, because none of these cases gonna hold. Don't forget that case 3 has some requirement. know n equal to 0, no, that's not the problem. That's not the problem. For the first one is okay. But that's not the issue. That's probably fine. Does it make sense? This is the way when you say it is not possible, you need to use any of these shows that none of them is holding. So you have f of n there, n log n, you show if it's not asymptotically positive, so you do not can use this one, or if any of these not hold, this is gonna be the third case, this is not gonna hold. You cannot find any C between 0 and 1, you just need to show this one, and if you show it, that's it, done. Now, is it clear? Anybody has any question? The second question is like this. Like, this is some example, probably maybe you say, okay, you can apply or you cannot. This is the substitution method to prove T of n is O of n log n squared. N log n squared. So, what is the answer? I need, the answer takes time, so I need to go through all the examples. So if I want to write the like the solution, I need to prove everything. So I just show you guys how you can find the answer. So probably one more thing I want to mention, go through the notes before the exam. I know you don't need to memorize everything because it's open book, but just go through the notes. At least, for example, you know when is master theorem coming, or if you want to write a note for yourself as a 1 page of everything, like master theorem, what is substitution method, what is the other methods, just write them in one paper. So at least you know when you use substitution method, you remember we say T of a smiley face is equal to, for example, 2T of something. What is it? So it's 2T of smiley face plus smiley face log. Like that was the way that you do it. Smiley face log smiley. This is the way that you do it, for example. This is a substitution method. You just go step by step. You need to just prove based on substitution. Is it clear? If you need to do these things.
Yep.
Okay, great. So now you know, for example, this is some of the kind of question that we have. Okay, so this is the experiment. One question is going to be exactly about the pseudocode of one algorithm. So, and then prove it. There's two possibilities. If I give the code like this, that's one possibility. If I ask you guys to write the pseudocode, but probably it's easier if I give you the code myself, pseudocode. So probably I will give you a pseudocode like this. You need to just show it by induction, find the recurrence T on relationship and prove it. The other one is going to be using master theorem. And if you don't use master theorem, use the substitution method, or you're finding the exact solution. Does anybody have any question up to now? Anybody, or we are good?
I get it so far.
Why? I'm so sorry, I didn't hear.
I get it so far. Sorry.
No worries. So let's see. Okay, this is one part of the question. So, and then the other one is gonna be There are three type of question. One of them is proving the algorithms that using master theorem or use substitution to find T of n. The other one is writing a pseudocode, prove this by induction, show the recursion, and then prove it. That's find the solution or prove it. The exact same thing, find T of n. Another kind of question that's going to be in the exam is coming from like finding the lowest, highest, and asymptotic growth rate. So like, for example, so one of the questions is part A of this kind of question. This is only connected about big theta, big O notation, big omega. Okay. When I say rank them from lowest to highest, it means one of them is going to be lowest, one of them is going to be highest. Let's start with, for example, 12n. And then what else? I have n, ln, n. I have 3, which is going to be n by itself. 4 is going to be ln of n. Then I have 5, which is going to be n. And then I have 7, like what happened? I have 4, 5, 6. What happened to 6? 6 is gonna be 2 ln. 7 n squared. 8 is gonna be ln of n squared, and then 9 is gonna be like a square T of n. So how do you solve this question? How do you find which one has the higher rank? Anybody know how do you solve this question? You want to rank them. How do you know which one has the lowest asymptotic growth rate? Which one has the like highest? Anybody, any idea at all?
Because they're graphing.
Graphic is not a bad idea, but doing this is not easy. How do you want to do all of this graph? So when you have f of n and g of n, how do you find this relationship? You remember? I said when is less than is like big omega, greater than is like big, and if it's between is like what, theta. Do you remember I explained this one?
Yep.
So if I want to say this one have the lower growth rate than this one, I just need to show this is going to be big O of this. For example, let's consider 2 of this. I want to say, for example, the simplest one. Like I want to consider n and n squared and go to infinity. This relationship is going to be limit 1 over n and goes to infinity. This is going to be 0. What does that mean? If it's 0.
It means the one on the lower is higher.
We said, but when it's between, when it's 0, you remember the graph. 0 between 0 and infinity, and it's going to be infinity. Remember we discussed about this. We say this is big small omega. You remember we calculate this one. Say this is a small omega, this is theta, and this is a small o. So it means this is a small o. It means n is less than n squared. So this is the growth. So I found this one of them. So I just say, okay, I know this is going to be this one. Let's move to another, like this one. Now I know this one is less than this one. Let's consider this, the second one. Second, let n divide by 2n, n squared. What is this limit? What is
0?
this? No, it's not 0. Because the growth rate of 2n Yeah, it's 0. Yeah, you're right. It's 0 because it's going faster. Yes, it's 0. It means that n is less than 2n, you know. But I know n is less than 2n, but I don't know is n squared less than 2n or not. I need to calculate that one too. It's okay. Now I need to do something because I want to find the limit. So it's okay. Let's calculate n to 2n and if what is this one? This is exact 0. So what is that all of this means? I know n is less than 2n, and sorry, I know this is less than n squared, and n squared by itself is less than 2 of n. Now I found between these three. I know this is gonna be, this is the gross rate. This one is that. Now I have these three, 1, 2, and 3. Let's do this one actually. So I say I know the smallest one is this one, and the biggest one is this one. Let's see it belongs to which of them. I say okay, limit of n divide by n go to infinity. This is still 0. It means this is going to be less than this one. So probably it's going to be this. Then go to n squared 2 of n. Now I found this 4. Does it make sense? Up to now.
Yep.
Okay. Now we do have these ones. I look at this, I look at this one. So let's look at n log n. So I will say, okay, n log n probably is greater than n because there is still one n there. So it's okay. It's not going to be here. Let's consider here between these two. Because I know it's not near as n squared, it's less than, it's okay, okay. I say, okay, limit of n by n log n goes to infinity. This is still going to be 0. It means it's in the middle. This is going to be like this one, n log n squared, and this one. This is going to be up to here. But here you need to check this one, make sure too. What do you do? It's okay, I want to do this one again too. It's okay. N log n divided by n squared, n to the infinity. This is still 0 because n gross is greater than log. So it's going to be, this is going to be true. I just showed this is going to be true. So I already showed all of this. I only showed this one. I showed this. How many is still there? What is this number? If I want to consider, what is this?
N to the power of 1.5.
This is going to be 1.
1 plus 1/2, right?
Yes, 1 plus. Yes, it's going to be 3 over 2. Does it make sense? This is 3 over 2. It means for sure this is going to be greater than n because this is going to be greater because, and this is going to be less than 4 because these numbers, this is 3 over 2 and this is going to be number 2. So this is probably, we can calculate, but probably this is going to be the case. Is I know it's greater than n. I know greater than n. I know it's less than n squared for sure, but I don't know, is it greater than n log n or not? I say, okay, let's consider n log n, divide by n here to 2. N goes to infinity. What is this gonna be? It's gonna limit of log n, this is gonna be n over 2, n squared. Which one is gonna be faster? Anybody? You say it's 3 over 2 is faster. So it's grows, which one grows faster? Like, so yes, this is gonna be worse. So this is gonna be still equal to 0. So now we know it's less than n. So it's gonna be here. What was that? N log n, and this one, n squared and 2 of n. We already calculate all of them up to now. Okay, we have this one, n log n, and then what else? N squared 2 to the power. And you need to keep going, you know, there is, I think I'm not gonna continue. So we have, I think this one, you need to do this. You need to do this one and this one. You just don't forget these three. I already removed this. Let me see. No, what was that? What was the first one? Okay. These three, you need to just make sure these three. For example, this like 2 to the log ln of n, you need to compare it with this one. We have 2 to the power of n. You need to consider it with this. Because 2 to the power of something has faster, so you need to compare this one. Just do these things and just you can write this part. Does it make sense?
Yep.
Okay, this is one of the questions. It means you calculate this thing, you use this limit and find it. Another problem is that the kind of question be like this. Like, okay, I just want you guys to say, okay. Let me see. You can have an induction problem, another induction problem. Like for example, what? So we have summation of like k equal to 1 to n, h of k, which is gonna be n minus n plus 1, h of n minus n. So what is h of n? I know h of n is gonna be like summation of k from 1 to 1 over k. This is h of n. So it's okay. I know I want to show this one for all n greater than 1. Use induction to prove this one is correct. Okay, let me write it better actually. Very confusing. So number B, the nth harmonic number is defined to be h of n summation of k 1 to over k, and then use induction to prove summation of k plus 1 to n hk is equal to n plus 1 hn hn minus n. We want to use like induction for all n greater than 1. There is one hint I can add here. Use the fact that h of n minus is equal to h of n minus plus 1 over n. You will find this one from here, you know. This is the definition of h of n. So you know h of n, you just want to show that this summation of this h of n is going to be this number. Just use induction. You just find the base case, so we assume it's going to work for m minus 1, so we prove it's going to work for m. Just note, write all the steps. It means that you say, oh, I assume induction is true, I'm going to write all of them. Yeah, it's going to be like some problem, like the midterm question is going to be the sort of induction problem like this. Or like the question about the sorting algorithm, and then the like asymptotic notation. Some of this kind. This is going to be 3 categories, or like notation, asymptotic notation going to be maybe different, just prove it, but this is some of kind. This is the 3 topics that we already teach. So I already taught. So this is going to be This is going to be the exam format that we are going to have for the midterm. Is it clear?
Yep.
You guys can start solving this question, and then this problem, and then if you have any question, we can talk about it on Monday, because the midterm is on Tuesday. Sounds good?
Okie dokie.
Okay, any other question? One more time, so it's really clear. Midterm is on Tuesday from 5 to 7. So from 5 to 7, and then it's going to be open book, but make sure if you use any resources there. And what else? So this is the type of question going to be in the quiz. Induction going to be in the quiz. The asymptotic notation, different version. Maybe I ask like a growth rate. I'm going to maybe ask like homework to just prove something. And the last one is going to be any algorithms, and then you need to show it with the induction, show the T of n, and master theorem. And another question was like showing the T of n by recursion. So how do you, if you can use master theorem, or you can use substitution and the other algorithm to prove this. Does it make sense? Not 3 questions, but some of the question is going to be part A and B. But what I'm going to do, I'm going to make it a little like easy to just solve it in 2 hours. But you have resource, you can just, for example, for calculating like if this n squared is greater than n, you can just search it in internet and plot them, which one is faster, you can write. So probably it doesn't take long. Just want to be really clear. It's easier if it's like a closed book. You need to memorize all the master theorem and everything. Question type is going to be one question type is going to be proving the master theorem, or is it work or it doesn't work. Use a substitution method to prove the T of n. Then one sorting or any other algorithm, you need to prove it by induction, find a relationship, show the master theorem for that relationship. Another problem maybe induction, like growth rate or asymptotic notation. That's the categories that we are going to have for final. Probably something similar that what I wrote all the things here today. So probably first question or third question is going to be one algorithm. You just need to prove it. Does it make sense? Please, if something is not clear, I swear I don't know what's going on in your mind. You need to talk right now. So probably I'm not going to guess it. Anybody has any question before the midterm? Yeah, 3 questions, but question have part 1, B, or C, something like that. But they are going to be shorter. So one more thing. If you want to type it, go for it. Up to you. If you want to write it in a paper and scan it, yes, go for that too. That's not a problem. But still, just one more thing. So for example, I wrote this one. I use master theorem from the note in the class. For example, this is one citation. If you want to copy paste something. Another, I use CLS book to write this equation. Yeah, the question is going to be similar. It's not going to be exact same thing. Don't expect it's going to be exact same. It's like similar format, similar example, similar thing. You know, when I say, okay, use this mean, it means whenever you use something, for example, if I use this one, This one, I use it from one book, just put like one number, different things, and just, okay, I use this one, just reference whatever you use. It's okay if you use it like because it's open, but just reference it like.
So Professor, if we write in the paper, so we'll get the extra time to upload our work.
So just scan, like, so you have 2 hours. Consider, I don't know, like 15 minutes, last 15 minutes for uploading. Just start for 1 hour and 40 minutes and make sure you have 15 minutes to upload. This is like, you didn't need to scan, take a screenshot of. Does it make sense? I can do, you know, probably most of you guys, you're gonna nag after that. Oh, our class gonna be finished at 6:40 and then the exam was more. But if you want, I can have the quiz to like 7:15. And you guys have 15 minutes more to upload.
Okay, perfect.
Yeah, I just want to make sure you're not going to nag about it later because it's more than like our class time. If you are okay with that, so it's harder for me. I need to stay more than our hours of class, but I can stay up to 7:15. You can upload everything. You have 15 minutes more. Is it better?
Yes,
Anybody-
thank you. Yeah, thank you.
Anybody has any issue with this? You're fine with 15 minutes more. Sure. I think that's fine. So I will give you 15 minutes more when the home midterm exam, so you can see it's the start from 5 to 7:15. So you have 15 minutes more for just uploading. Write whatever, anything that you think is correct, just all the steps, everything. Just be really clear. I'm gonna do 2 things. I will send an announcement for the midterm. I will upload probably tomorrow evening. I will upload the solution. I will start grading all everything, so you know the solution and everything before the midterm. Sounds good?
Yeah, so we don't have any homework before exam, right?
No, I postpone it because the homework has some question that is gonna be more than the midterm, so I didn't want to push pressure on you guys. That's the reason I postpone it.
Okay, perfect. Thank you.
You're welcome. Anybody has any other question, anything want to mention? If you don't have anything to say, just have a great evening, have a great weekend.